Hey everybody, how you doing? My name's Aaron, and I'm a developer advocate at Ditto. I've been building software for professionally for 30 years, and I love helping developers build great software. With the introduction of the iPhone in 2007, the world of mobile devices has changed dramatically. Mobile devices become more powerful, more capable, and more essential to our daily lives. In today's business landscape, mobile devices like phones and tablets have become essential tools, not just for communication, but as for core platforms for running entire operations. Across industries, these devices are driving billions of dollars of revenue by enabling teams to work more efficiently, access data on the go, and make real time decisions. But it's not about just the individual productivity. The true potential is unlocked when these devices work together, when they collaborate seamlessly. Think about the last time you went to like a restaurant or like a concert or even like a factory. Chances are the people you interacted with were using mobile devices like this phone and tablets. So, who has migrated to mobile devices over the past 12 to 16 years? Let's look at some examples. So, flight attendants, they use them for communication and for customer service. Ground crews use them for logistics and operations like baggage tracking, and pilots use it for navigation and flight management. Restaurants use them as a point of sale system, with everything from managing which tables are open to taking orders, helping kitchens see quickly when new orders are coming in, all the way down to processing payments. Workers in factories and warehouses use mobile devices to track inventory, management shipments, and streamline production processes. In this new world where edge devices are becoming essential, eventually the data needs to connect to your private cloud or to the public cloud for further processes and analysis. In the airline industry, for example, that means I get a notification on this mobile device that my luggage is on the plane for my long trip to London. And believe me, nothing solves travel anxiety like knowing that I'll have clothes when I make it to London, right? In the restaurant industry, this means overall information about sales, inventory, customer preferences, and operational efficiency can be sent to be analyzed, leading to better service and increased profitability. Now, these are just a few examples of how edge devices have transformed operations across various industries, enabling teams to work smarter and more efficiently. But there's a common thread that runs through all of these examples: the need for connectivity, even in challenging environments. It turns out at the edge, it's a very unpredictable environment. Network connections can be surprisingly fragile. Wi Fi can go down because of interference. Physical barriers are just being too far from the router or access point. Cellular networks can struggle in rural areas during peak usage times or at crowded events like outdoor concerts. And sometimes it's completely out of your hands. Like, for example, when a construction crew cuts a fiber line or a storm takes out services for several days. So we know these edge devices are essential. We see them everywhere. But how do we ensure they remain functional in these unpredictable environments? Now, I can describe some ways the industry has used to solve this problem in the past. In many ways, they're still trying to use it today. And that is just add more hardware. So let's take a look at this. I'm going to open up a little diagram I can draw on here, and let's diagram out how people used to go through and try to solve this problem. So let's start out with on this blank slate by adding a server. Everybody knows that we have servers, they host our databases and stuff like that. But if the server goes down, I'm going to need another server for backup so that, I don't lose service, right? So let's add two servers. Well, now I've introduced a problem. With two servers, I need to be able to know which server to use, right? In case of this one server goes down. So I'm going to need something called a load balancer. Okay, so I'm going to add a load balancer to my diagram. But the servers also need some shared storage that they can use so that the database doesn't have to, move between the disks on the physical servers. So we'll add a SAN, a storage area network, right? So now we've got a pretty decent setup here, but we also are going to need a network switch, right? A pretty big one. We want very fast speed so all this data can move across and stuff. So we'll add a network switch to our diagram. Now, we talked about it earlier, all information's either in your public cloud or your private cloud or the public cloud, right? So let's add a cloud to the diagram. And to connect to the cloud, we're going to need a router of some sorts. Let's go through and add a router. So let's go through, add a router here. Now, we all know security, right? You can't just be adding routers. You need to add a firewall in order to guarantee we have security, right? So we're going to add a firewall between our router and the cloud to guarantee that, hey, we can guarantee our information safe and stuff, right? And we're doing pretty good here, right? But now we need some edge devices. So we're going to add in, I'll use an example of like if you're at a restaurant of some sorts, right? So I'm going to add in some order terminals here, sprinkled throughout the restaurant. So we'll just do 3 for the simplicity here, right? We need a kitchen display unit because that's where the order is going to go through. So they make sure that they're making the food I need, right? But people may also be making orders on the phone. I talked about that earlier. So let's throw out a phone here. And then also through tablets. So let's add a tablet in here. So maybe this is a tablet in the actual store. People are making orders, right? Well, in the particular restaurant stuff here, we're going to need the ability to connect all these edge devices together. So let's add in a bunch of access points. That solves the problem, right? To guarantee we have connectivity, we'll add an access point over here. One more. Our stores may be bigger, or our restaurants may be bigger, so we probably need to add we'll say 4 access points, right? Now, this is starting to look pretty good. And if you've been doing this for a while, this seems to look like pretty normal, right? But all this equipment, it needs to be stored somewhere. So now we have to go find a room to put it in, right? And I'm going to make the assumption that you have like a backup generated power. Now, what most people don't realize is that when the power flips from the street to your generator, that's going to cause a little blip. So because of that, you're going to have to probably put some UPSs in the rack, right? With all this equipment so that the servers survive that blip. And also guarantees that the power supplies don't go bad when this happens, right? Now we've got a bunch of equipment and that's going to need cooling, which means you're going to have to add in an air conditioning unit. It's capable of cooling this room without adding moisture because that's bad for equipment. So you're going to have to add that in now. And you think, okay, well, you're describing these things. I can handle most of this, but we're forgetting another crucial piece of all this: people. We need a team of IT professionals to install the software on the servers, manage and maintain all this hardware and software together. Now, this sounds intense, and it can be. Let's go back to the original goal, right? All we really wanted was for workers to use this order terminal and share information over to this kitchen display unit so that when they do stuff, that the information syncs back and forth between here, and then also so that it makes it to the cloud, either the public cloud or your private cloud, once an internet connection is available. Why does it have to be this hard? Well, this is where Ditto comes in. Ditto makes you look at this problem from a different perspective. Let's talk about how Ditto could solve this problem. Today, we're making apps that run on these edge devices, but we're still thinking of cloud native and centralization for our data. But what if we were to flip that on its head? What if we were to think of edge devices as the center of our data universe? Ditto does just that. It's a modern, edge native, decentralized data platform that allows edge devices to operate independently, even when disconnected from the cloud. Edge devices are so powerful today that they don't need central authority. Modern mobile devices like this iPhone right here or this Android phone here are like supercomputers in your pocket. It has the same processing power that was used to run data centers less than 10 years ago. So how does Ditto work? Let's start by taking this diagram and put another slate on here and talking about what it may look like if we were to use Ditto instead. So I'm going to go over here. I'm going to grab another frame here and I'm going to paste this in. We'll move it around a little bit so that we can see it. Let's do this here and then hide that there and then maybe zoom in so you can see a little bit better. Hopefully that's good for everybody here. So let's start by just taking out the things we don't need. So we don't need servers per se with Ditto, at least not in the restaurant. You don't need a SAN or a load balancer. In fact, you don't need all these access points. You probably can get away with just a couple. Okay, that's going to be, everyone's going to go, what, really? Right. Now, as you can see, Ditto isn't a replacement for the cloud. I still have it in the diagram, right? It just makes it easier to continue to operate when you don't have a connection available to it. Now, also, I'd have to say that because of the fact you have less hardware, you probably can get away with cheaper network switch. You're going to still need something to connect these access points and stuff, but you don't need like a 10 gigabit switch necessarily to do that, right? So you may be able to reduce the hardware type that you're putting in to be a little bit more cost effective, right? So, giving all this information, let's dive into how Ditto works. Let's look at this order terminal. We start with an offline database that runs directly on that edge device. This database is lightweight and efficient, designed to operate within the resource constraints of a mobile and embedded environments. It stores data locally, allowing the device to function fully, even without an internet connection. When we look at the various edge devices on this diagram, how is Ditto different from the previous architecture? Well, Ditto can use peer-to-peer mesh architecture that allows the device to communicate directly. No central server, router, or access point needed. If you're thinking to yourself, well, then what's the difference between peer-to-peer Wi-Fi compared to using Wi-Fi? Let's say, for example, a wireless access point. That's a great question. Let's go over that real quick. With Wi-Fi and an access point, it requires all devices to go through a central hub, like a router, a hotspot, or an access point, which manages communication between them. Peer-to-peer Wi-Fi, also known as Wi-Fi Direct, allows devices to connect and communicate directly with each other without the need of a router, an access point, or special hardware. This direct connection with peer-to-peer Wi-Fi reduces infrastructure dependencies and enables faster, more resilient local communication, especially useful in edge environments with unreliable connectivity. The amazing part of all this is that you can use both of them at the same time. So let's take a look at this in a little bit more details. So I'm going to zoom in here and make sure that you guys can see this well. Hopefully you guys can see it well. All right. Unlike traditional star topologies like I drew earlier, where all the devices route traffic through a central hub like a router or a switch, a mesh network supports multiple redundant communication paths between devices. Ditto builds this mesh using a combination of transport technologies, including Bluetooth Low Energy, peer-to-peer Wi-Fi, and local area networks. This process is entirely seamless and platform agnostic. For example, I can take this iPhone and this Android phone, and they can discover each other and sync data directly without any special configuration or complex discovery code. When multiple connection types like Wi-Fi, Bluetooth, and LAN are available, Ditto can use all of them together and create the strongest, most reliable link between devices. Now, behind the scenes, Ditto's multiplexer figures out which transport is best at any given moment and automatically switches between them to keep the connection stable. This smart combination of different transport types is what we call the rainbow connection. It's where each color represents different way devices can connect and work together. And you can see that at the diagram down here where we have all those. The amazing part is that this single device can use multiple transports at once, creating a robust and flexible network that adapts to the environment. Like I said, when we look at this diagram, it's cool because you may use peer-to-peer Wi-Fi to connect to a nearby tablet. Maybe you're using Bluetooth Low Energy to sync to a smartphone. And you can use another wireless access point to communicate with an Android-based thermal printer, all at the same time. This means that even if one transport fails, the other transports can keep the connection alive. I'll move on to the next slide here. This also can be used to extend the range of the network, allowing devices to communicate over longer distances by hopping through data through multiple devices. Ditto also handles syncing to the cloud automatically. Whether your public cloud or private data center, once the connection is available, ensuring data is up to date across the system. Devices will continue to operate offline for long periods, storing data locally and syncing seamlessly when reconnected. You can see this in the diagram. We have our source device over here, and it's syncing through all these different devices to get to the target device. And it doesn't matter if the access point's up or down. And I know it's hard to see in this diagram, but you can see that each one of those syncs, the network connection is a different color, which means it doesn't have to be the same technology, right? This is some just amazingly cool stuff that it does, right? Now, Look, let me scroll to the next slide here. Look, I know what you're thinking, and it is the elephant in the room. Okay. What if a device is offline for too long? Won't there be conflicts? You're absolutely right if you're thinking this. Anyone that's done a tricky git merge knows the pain. But this is where Ditto shines. Under the hood, Ditto uses CRDTs. These stand for conflict free replicated data types to resolve data conflicts automatically. It does this by storing a small amount of metadata with each document, allowing it to merge changes from different devices, even when they modify the same data concurrently without the requiring of manual intervention. Look, I know this sounds kind of like magic, and it feels like it when you're using it. But I promise, Ditto doesn't break any laws of physics or computer science. The SDK just makes complex distributed systems feel easy. And honestly, this is one of the reasons I joined Ditto. After 30 years of building software, discovering a platform and an SDK that lets you add real time syncing, peer to peer communication, and offline resilience, all without writing your own networking stack, come on, it's rare. A multiplexer that chooses the best available transport for you? It's just so simple. It works, and it saves you months or possibly years of engineering time if you try to build a subset of this stuff yourself. And look, as a developer, I want to focus on building great apps, not managing infrastructure and technical debt. I've spoken to developers all around the world, and so many of them feel the same way. That's what Ditto enables. And that's why I'm here today sharing it with you. Now, with some background on how Ditto works versus how you may go solve that problem with more hardware, let's look at the two again, right? So I'm going to go back here in time. Let's go look at frame two, right? So I have this diagram, right? On this, we have this, you're investing in really complex stack of hardware, infrastructure, and IT professionals just to make these two devices, this ordering terminal and kitchen display, communicate, right? Let's go over and look at Ditto. And get this over here, move this out here so we can see it, right? But if we look at it from Ditto standpoint, you achieve the same outcome when you're using software, leveraging the power of the edge hardware like phones and tablets to create a simpler, more scalable, and resilient solution. And a reminder, as you can see in this diagram, it's not all the devices that need to connect to the internet or to the cloud to be able to sync information there. On top of this, Ditto has optional features that allow you to directly connect to your existing systems like MongoDB Atlas, meaning you don't have to migrate all your data to a different platform just to get these cool edge features. Now, don't take my word for it. There are many companies already today using Ditto to build the next generation of applications and services. One customer that comes to mind is Chick-fil-A. Get rid of that so we can see it better here. Chick-fil-A is a popular restaurant chain in the US, noted for its delicious chicken sandwiches, which I greatly enjoy. Customers have several ways of placing an order. They can make it through the mobile app for pickup. You can go through a drive-through, or you can order inside the restaurant. During busy times, employees even take orders outside using tablets to help the kitchen stay ahead. So by the time you reach the drive-through window, your food is ready and waiting for you. In all these scenarios, information is coming from multiple sources, whether it's that mobile app, the drive-through point of sale system, or an in-store terminal. Regardless where the order starts, all the data needs to read the kitchen display so staff knows what to prepare and when. Ditto makes a huge difference because it doesn't matter where the information comes from. It can seamlessly sync across all these devices without the need of complex infrastructure I showed earlier. Look, let's take a look at this from a second from the traditional standpoint, right? So here I have, a traditional and simple point of sales architecture diagram. As you can see, when an access point goes down, various devices no longer have access to the data required for the application to continue to function properly. Also, when the server loses its connection to the cloud, that means orders coming from the public mobile app will not make it to the store for processing. There's nothing more disappointing when you get there and your food's not ready and they don't even know that you made the order, right? Nobody wants that. So let's take a look at Ditto here, right? So let me scroll over and look at a Ditto slide. If the access point goes down, it's not a big deal. thanks to peer-to-peer mesh networking Ditto creates. Each device connects to another using multiple network technologies. So if one connection fails, Ditto automatically switches to another, keeping data flowing smoothly. And this is the power of Ditto. It doesn't just rewire how data flows, it reshapes how we think about architecture. Look, the cloud isn't going away, but it's no longer the center of gravity. With Ditto, your edge device becomes a first class participant in your system, capable of collaborating, syncing, and scaling with minimum infrastructure. And that means a future where real time, distributed, offline first apps aren't just possible, they should be the new norm. Now, look, I've been building systems a long time, and I know the pain of duct taping together unreliable networks, retry loops, reachability frameworks, sync queues, and cache strategies together. We've all been there, right? What makes Ditto different is that it actually solves the problem in all these hard problems for you with tools that feels like they're made by developers for developers. Look, if you're tired of reinventing sync or wrestling with unreliable networks, Ditto is your shortcut to building great software without all the overhead. I want to thank you for your time. Look, I know it's busy, and hey, finding 25 minutes to listen to a person like me is hard. This is the first of many conversations I'd like to share with you in the future. If you have questions or things you'd like to see me talk about in the future sessions, leave me comments and I'll get back to you because I'm really interested about this. Now, I want to pause for a moment and see if we have any questions I can try to answer. I'm looking through here to see if I can see any questions. Oh, it looks like the crowd may be a little, hey, look, I get it. In the West Coast, it's really early. So if you don't have questions, that's cool. What I can do is I can share with you a couple questions. Okay. Oh, it looks like we have one coming in. Okay. So, you know, throughout the presentation, one of the things that comes up, and honestly, I've heard this before. A lot of people ask, well, are you saying we don't need the cloud anymore if we use Ditto? It's a great question, but like I said earlier, Ditto is not a cloud replacement. It's like a powerful complement. It brings like resilience and real-time syncing to environments where cloud access is unreliable or just flat out not available. Think of Ditto as like extending your architecture to the edge. It syncs data peer-to-peer when offline and then automatically syncs it to the cloud. And it could be the public cloud or it could be your private cloud in the data center when it's back online. And the best part is you don't need to rip out all your existing systems. Ditto plays nicely with your current setup, making multi-hop to cloud seamless, unlike some platforms that force you to do a full overhaul. We have to take your data out of your current existing systems and then migrate it over here. That just seems like a lot of risk. That just seems like a lot of work, and it seems to be really expensive, right? So Ditto can solve these problems for you. Let me check here and see if there's any other things going on here. Let's see here. This is let's see here. Can you talk about Ditto's access to data's subscription capabilities? Let's see here. So we've got a couple of questions going on here. So Andrew's got a question about that. So what subscriptions are, and this is kind of interesting, is that you may have in some platforms they sync all the data down to the device, right? To this edge device. And if you think about it, do you need all the data on this phone? Let's go back to that restaurant example. It happens to be the architecture diagram I have open, right? If you're a restaurant, you don't need every order that's ever happened on this device. You may only need the last day of orders, or maybe even the last 4 hours of orders, right? So what a subscription allows you to do is limit the amount of device that you actually sync down to your edge devices so that you're only getting the information that they need and when they need it. When the data comes out of the subscription, say, for example, we say, give me all the data for today. So when the next day rolls around, the data is automatically removed from the device. You don't have to do any work on that because it doesn't meet the requirements of the data that you're subscribing to. This makes it way easier to actually go through and then not have to worry about overloading a device like this with an 80 gigabyte data of all your orders for the last month, for example, right? We want to keep the device running smoothly and only syncing information that's relevant to making business decisions. Subscriptions help us get there. So there's a LinkedIn user here, a random user that says, what do you run on the access points? Okay, that's another great question, right? So the access points are, I think of are like LAN, and you can run sync on those. It's just, it's not required. If the access point goes down, you basically can sync across peer-to-peer Wi-Fi instead. So think of it like having multiple ways of getting to, say for example, you're in your car, right? And you want to go to the local store, and I don't know what country you're in, but maybe it's like Walmart in the US or H&M if you're over in Europe. It doesn't matter. There's multiple ways of getting to the store. Okay. If you think about that, you're in your car, you're driving, your GPS will give you the best possible way. But what happens when there's road construction, something like that, right? Your GPS is going to reroute you a different path and say, look, this is the new shortest path there, right? That's the best way to get there. That is what Ditto is. So what we have is that the access point may be the best path right now to sync information between devices. But if the access point goes down, we can say, look, we don't need that anymore. We'll reroute it and we'll actually go through then peer-to-peer Wi-Fi. Or maybe we'll use Bluetooth, low energy. That's the power of Ditto, is that it will figure out what the most efficient way to doing that is, depending on what type of network connections are available on that physical device, right? I think about that Android thermal printer, for example. It may have a Wi-Fi connection point in it. It may have an Ethernet port in it, so you can plug in a LAN port to it, right? And since it may also support peer-to-peer Wi-Fi and Bluetooth. Well, then you have all four of those available. And if the Ethernet cable gets pulled out by accident, you still have all the other three ways of syncing information between those two devices. So basically, you can use the wireless access points to talk between devices, but it's not required with Ditto. It's just another vehicle, another way of getting your data to wherever it needs to go. But like your GPS in your car, it's not the only way. And you can, just like your GPS in your car, be rerouted, and the data can use other ways of getting the data to where it needs to go. And that's probably the best analogy I can come up with. All right. Hey, man, thanks everybody for the questions. That was great. And like I said, post in the comments if you have other things you want me to talk about, or if you have other questions. I'll be watching and I'll be more than happy to answer those. Now, one second here. Let me scroll down here. Look, if you want to try out Ditto, you can find out all the information you need from our public website, ditto.com. If you're a developer and you want to view documentation first, that's what I like to do. You can do that from our docs at docs.ditto.live. Now, if you want to see a more detailed demo of this technology in action, you can schedule a demo from our main website. Okay? I want to thank you. Take care. And remember, as developer and technologists, we're all in this together. Have a great one, and I'll see you around on the next one.